We are recording. We are good. Okay, write that down. So that's what we're going to look at now. Resolving vectors. Let's have a look. You got the title? Yep. Okay. So horizontal and vertical vectors can be added together, just like any two vectors. So no, I don't need to write anything. This is motivation. Horizontal and vertical vectors can be added together, just like any two vectors. There's nothing special here. And this is common. But also what's important is if you have the resultant, what was the two vectors you added together? Okay? Do you get what I'm saying? So, if I have two vectors, look, there's A, and then there's B, so there's A plus B. Okay? Resolving means they're opposite. So there is A plus B, and you want A, and you want B. Okay, so this is what resolving means. It means go backwards. That is, taking a vector and writing it as a sum of the horizontal and the vertical. So, in other words, resolving means going backwards from the resultant. So it's enough even just to write that down. Resolving is going backwards from the resultant. So just write that. Resolving is going backwards from the resultant. Okay? Don't worry about that. If you really want to write that down, you can watch the video and write it down. Okay? Now, Pythagoras. You learned about this in middle school, and it says, as you just saw in the lesson previously, it's useful for vectors. A squared equals b squared plus c squared. You all know this from middle school, okay? But maybe you don't know the English name for it. I know in Arabic it's still Pythagoras. Yeah, and you have to study in English, but I know Chinese, what are we talking, Gogo-D or something? What's it in Chinese, Pythagoras? No, that's not what I was told. That's the one, yes. Say it again? Deeply?
It's like Google.
Like Google, okay, I'll remember that. Well, in English, Pythagoras. Is it still Pythagoras in Korean, or it's the same? Yeah. Okay. So only the Chinese students need to maybe write this name down. So Pythagoras. Okay. Yeah. It's Pythagoras for you as well, isn't it? In high school. Yeah. It's still the same. What's that? Well, what is it? Somehow I don't think so. Okay. So really it's the word here you need to know, Pythagoras. Okay, so I don't even think I need to do this example. I want you to do it for me. So we have 3 meters east and 4 meters north. Give me the magnitude of the result. So you'll need to use Pythagoras. 3 and 4. Give me the result. How big is it? 5, isn't it? Yeah. Because it's 3 squared plus 4 squared equals x squared. Yeah. So that's 9 plus 16 equals x squared. So 25 equals x squared, so x is 5. But I mean, I would hope you remember this from middle school, right? It's middle school. Yeah, I wouldn't even say it's high school. Okay, so the answer is 5. Now, more vocabulary. So these are the names of each side. Opposite, adjacent, hypotenuse. Okay? So I want everybody to write this down because we'll need to use this triangle for something in a moment. So draw this for this side. Go. And please note, hey, don't talk when I'm talking. Please note where the angle is, okay? Yeah? Not yet? Yes? You got it? Okay. So, opposite, adjacent, hypotenuse. So, we can use Pythagoras to find the magnitude. If you want to find the angle, you see the angle? You need to use this formula. Now, I am not going to talk about this formula in physics class because we will do this in maths class. Alright? So we will do this in maths class. I'm just going to give you the formula. This is how you can calculate the angle. I'll show you. No, all will be explained. Give me a calculator. So for example, in the example we did, how big was the adjacent? In the last example we did. In my question here, this one here. How big was the adjacent? 3. And how big was the opposite? 4. Yeah? Did you write it down? Yeah. So it was 3 is east, so that's that. And 4 is north, so that's the opposite. So what I want you to do now, on your triangle, write opposite equals 4, and then adjacent equals 3, wasn't it? Is that the right? Yeah? Yes. Right. Do you have your calculator? No. So what you can do is you press normally shift, and then tan, which is there, and then we have -1. Yeah, that's when you press the shift. Yeah. And then what's the opposite? 4. So it's 4 over 5. Right.
To remember this.
Okay, right, so can you see that there?
Yeah.
That's what it will look. No, sorry, not 4 over 5. 4 over 3, wasn't it?
4.
Yeah, so you can see, I can type it in the calculator like that. Yeah. And this will give me the angle. So the angle is 53, is the angle. Yeah, so this is why you need a calculator. Do you have a calculator?
No.
At home? Oh, so you need to buy one. Please do. And do you have a calculator?
Yes.
Now?
No.
And you have one, yeah. You need to buy it? Oh, it's the same. But no. Yeah, we will do all of this in math class. For physics, we're going to keep it simple, one formula. Yep.
Many.
Yeah, for physics, we just, for now, just one. Okay? So,
This first time.
So my next question, you already did it. What is the angle? So what's the angle?
Oh, 53 degrees.
Yeah, so east, 53 degrees north. Yes? East, 53 degrees north. Perfect. Yes. Now, these are, you know these, yeah? So, we have sine cross tan, and these are the formulas for sine cross tan. Again, I will talk about this in math class, and I hope you did this in middle school. Yeah. So, we are just going to go through it very quickly. But please write the three formulas down. Sine, cos, tan. Okay. Did you write those formulas down? Yeah. Okay. So these formulas are useful because if we know the magnitude and the direction, then we can work out the opposite and the adjacent. So basically, this answers my question I gave you at the start of the class. So, what does the word resolve mean? It means to take your vector and to write it as A plus B. It means to go backwards. You remember that?
Yeah.
So, let me actually show you how we can do that now.
You can use angles to...
Yeah, let's have a look. So, again, it is working. Okay. So, this is opposite, this is adjacent. Listen carefully, listen carefully. In red is what we want, and in blue is what we know. So we pretend, for example, I know the direction, and also I know the, what's this called? Hypotenuse, or if it's a vector, what's it called? The magnitude. So let me call this x. Or if you want, we can call it h, for hypotenuse also. So in blue is what we know, and red is what we want. So blue is what we know, and then red is what we want. And what's the verb? What am I trying to do here? What's the verb?
Resolve.
Resolve. That's what I want to do. That's the verb. Okay. So what I'm doing here is I'm showing you the formula to get the answer, okay? So for example, what does sine theta equal in your formulas? What's sine theta? Opposite over hypotenuse. So therefore, the opposite equals the hypotenuse multiplied by sine theta. And in fact, that's the first result. If you want the opposite, you just take this number and multiply it by sine of this angle. We'll do an example in a moment. Cos theta, what does that equal? Adjacent over hypotenuse. Therefore, adjacent equals hypotenuse multiplied cos theta. So in other words, this side here is h sine theta, and this side here is h cos theta. So if you know the h and you know the theta, you can also know the opposite and the adjacent. by using these formulas. This is something you will do a lot. So this is very important. Please write all of this down carefully. So please write this down, all of it. Got it? Yeah? Okay. No?
You know this word? This word.
Which word?
Sohcahtoa.
Yep. I know it. That's why I wrote it. Can I go down? Yeah. Okay. Is that yes?
Yes.
Yep. Okay. Let's do a small example. This vector has magnitude 5 and its angle, its direction is 53.1 degrees. So, some people have a calculator. If I want to know this part, I calculate 5 cos 53.1. Type that in, and what do you get? 3. We'll say 3. And then what do I need if I want this side? 5. Yeah. Sine 53.1, which is, type it in? 4. Which of course it should be, because I'm just doing our answer backwards of the example I gave you. So it should be 3 and 4, because that's what we just did. Yeah. Okay. So I haven't actually said this yet, but I think it's a good point now to say it. If you know what the velocity is, you can actually know what the speed is, because the speed is the magnitude of the velocity. So for example, let's imagine that this is a... No, it's gone again. Oh, no, it's back. It's gone. We are back. So let's say this is a velocity vector. So this is a person, he goes from here and he goes to here. And let's say this took 1 second, whatever. The speed is actually 5. Okay? So when you have one velocity vector, and I want to know what is the speed of this one vector, in fact the speed just means magnitude. This doesn't work if you have two vectors. So for example, if I have this one here is 2, and this one here is 3, the speed is not 5. What would you have to do? Well, what you would have to do first is add them together, and then the magnitude of the resultant is the speed. Okay. Anyway, please just note this. Speed is the magnitude of velocity. Yep.
You record only the screen.
Yeah. So you missed what's on the board. Yeah.
No, not on the board.
Yeah.
The say you think.
Oh, my voice is recorded as well.
Oh, okay.
Yeah. Okay, can I continue? Yeah. Okay, so here's an example. I have a vector that is 10 horizontal and 20 vertical. What is the magnitude and direction? So let's have a look at this one. So this vector here, I say, is 10 meters per second horizontally, and what did I just say? Oh sorry, I'm looking at the wrong one. 20 vertical, 20 meters per second vertically, and I want to know what is the magnitude and what is the direction. So how can I find the magnitude here? What do I use? Pythagoras. So 10 squared plus 20 squared equal to x squared. So that means x squared is equal to 300. Isn't it? No, it's not. Ridiculous. Ridiculous. X squared is equal to 100 plus 400. So x squared is equal to 500. So x is equal to square root of 500 meters per second, which is about 7.71? No, don't listen to me. Yes. It is 22.3 meters per second. Okay. I also want to know the direction. So what formula do I use for the direction? Well, which one did I give you? The first one. What is it? Tan inverse. What goes here? Yeah. Which is what number? 20. Yeah, so what's this, please? 63.4 degrees. So that's the answer. The answer is 22 meters per second, and this is east 63.4 north. Okay, so write this one down, please. Got it? Yep. No. Continue. Okay. Right, so this one now is the same, really. Yeah, it's the same thing, basically.
What was the answer?
The answer was this. Yeah, so I'll tell you what, I'll just give you the homework questions now. Yeah?
Only question.
Yeah.
For the direction, I don't know to write the direction is north. Only the number I can get is what the direction is.
Yes. So this one here this is east, isn't it?
Yeah.
East 63 degrees to north, and this, for example, is east 63 degrees to south.
I know, but how can I write this east and north? I know 63.4.
Yeah, but look at the picture. Imagine you're explaining this to someone. So if you explain it to someone, it's like, okay, it's east, and then do you go up or do you go down? Yeah, so that's why the north is there, because you go up. If it goes down,
I'll show you start from there.
Yeah, start from the ground.
Yes.
And go north or go south. So that's why north. Yeah. Yeah, I don't think there's much else to say. What I'll do is I'll put the questions up, and then once you write the questions down, then you can go. Okay? So I'll just put the questions up, write them down, and then you can go.